In this video, I'm looking at this problem here where we've been asked to find the pronumeral in the figure below. So this is our pronumeral here, x, so we just want to find out what its value is going to be. So to do this, we need to use similar triangles to help us out, because the fact that we don't have enough information to be able to find this x using something like Pythagoras or trigonometry. So what we'll do is first prove that the two triangles here are similar. Now our two triangles in this image is this one here, triangle PAB, and our second triangle is the one PQR. So that's what we want to do, is prove that those two triangles are similar. So to do that, let's first have a look at using which rule we can use to do it. So we've got two rules. We've got side, 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 or we've got angle, angle, angle. These two theorems are used to prove that triangles are similar, because a similar triangle has either the same scale factor between the three sides, or they share exactly the same angles. Now what we're going to need to use is the angle, angle, angle theorem, because we haven't got enough sides here that we can work out, especially considering we're trying to find one. So we'll use our angle, angle, angle theorem to prove that these two triangles are similar. So the first thing we can do is show that these two angles here, PBA and angle PRQ, are the same because they're given to us as being 90 degrees. So the angle PBA is the same as our angle PRQ, and that's given to us as being 90 degrees. So we can state that these two are the same because they're both 90 degrees, because they're given to us in the diagram. So that gives us one angle. We now just need to prove the other two. The other two that we can state are the same is that the angle APB is going to be the same. So this angle in here, APB, is going to be the same as the angle QPR, because they're exactly the same angles. This angle here at the point. So angle QPR are equal to each other, and we can say that they're equal to each other because they're shared. They're both exactly the same angle, and they're shared between the two triangles. So now we just need to prove our last angle, which is this one here. Now we've got two ways of stating that these are the same. We can use the fact that the three angles in a triangle add up to 180 degrees. So these two are the same for both triangles. So these two would have to be the same because they'd have to add up to the same number. Or we can use the fact that because this is a straight line and they're both 90 degrees, both the same angle, these two lines are parallel, which means that these two are equal given our F rule, or alternate angle rule, for parallel lines. So we can now state that angle PAB, so this angle in here, PAB, is the same as angle PQR, this angle up here, PQR, because of the F rule, or because the angles in a triangle are supplementary, or add to 180 degrees. Supplementary. Okay, so they add to 180 degrees. So that gives us the fact that these three angles, three matching angles in the two triangles, are exactly the same. So that means that we can now finally state that therefore triangle PAB, sorry, triangle, not angle, is similar, so we use the tilde for similar, to triangle PQR, because of the fact that we've proved it using the angle, angle, angle theorem. But that's not what we were asked to do. We were asked to find the value of x. So now we can use the fact that these two triangles are similar to find x, because of the fact that a similar triangle, or similar triangles, have the same scale factor between sides. So we can find the scale factor between this side and this side of the two triangles, and use that to find x, because it'll be the same as the scale factor between that side and that side. So that's what we're wanting to do now. So let's first have a look at the scale factor between these two triangles. So we got the triangle length P to B, and we'll have a look at the scale with it and the distance between P and R. So we'll have a look at those scales. So the distance between P and B is given to us as being 4. So we have 4. And the distance between P and R is 8, because it's these two distances put together. 4 and 4 is 8. And if we simplify this triangle, we have the fact that PB over PR 1/2. Okay, so now we have that PB over PR is 1/2. So now we can use this to have a look at these two sides and find x. So we have AB over QR, and that should be the same as this one here, so that's 1/2. And if you actually have a look at AB, that distance is 2, and the QR distance is x, and x is what we're trying to find. So we have 2 over x is equal to 1/2. So now we can apply some algebra, and we can multiply both sides by x. So we can have x times 1/2 is going to equal to x times 2 over x. So these x's will cancel out, and we're left that x times 1/2 is equal to 2. Divide everything by 1/2, so we'll have x times 1/2 divided by 1/2 is going to equal to 2 divided by 1/2. So that the half divided by half cancels out, and we're left with x, and 2 divided by 1/2 is the same as 2 times 2, so x is 4. So now we've found x. By using similar triangles, we've put together enough to be able to find our distance for x. But first we had to prove that the triangles were similar, then use the fact that these triangles are similar to find our unknown.